microphone in, is that all right?
That's perfect.
Okay.
Yeah.
So yes, we're going to talk about healing land and sea in an effort to fend off climate collapse. And I do acknowledge the traditional custodians, and Elly's going to be telling you some very interesting facts about the difference in how the land was managed before colonial times. But it might be, as always, is the climate endgame. I'm going to try not to dwell too long on this, but it's very important context. On someone like so many people who thought we had 100 years, that was back in 2007. I haven't thought that for a while. And it was the year of the big melt that sort of got me on board. The first big melt. There's been a lot of big melts since then. And the thing that really scared me was knowing, from getting on this mailing list from David Spratt and Philip Sutton, that the scientists were panicking. They were already panicking in 2007. They were already talking amongst themselves about whether they should buy land in Tasmania or New Zealand. That was in 2007. It was not being spoken about. So I have been involved in quite a lot of different campaigns, but about 7 years ago, which was around 2015, 2016, I just realised that we weren't going to make it. Like we had planned a 10-year transition that was meant to start in 2000 and finish in 2010, and 10 to 20. So it was 2015, and we were nowhere near. So I quit my job, and I've done a lot of things. But yes, Extinction Rebellion is my day job now, and that's the most exciting thing I've done. It was actually, well, somewhere between terrifying and exhilarating. And it does feel quite good to feel like you're doing something proportionate, as close to proportionate as people can do. Because, yeah, the idea of the end game, it comes from Schellenhuber. Well, it comes from a number of people, but this is a quote from Schellenhuber from 2018, and saying, back even in 2018, that we have to choose very soon between taking unprecedented action. Unprecedented. This is not just a bit more of the same. And that the issue is the very survival of the civilization. Like, with Extinction Rebellion, I've been on Talkback Radio and 3AW a lot. They have no idea. They do not accept. They think this is a fringe idea. I can't count how many scientists think this and have said it in various public forums. 3AW either don't know or won't know. Anyway, I'm not going to go through the horrors. Every time I do this talk, I could, start again with the different horrors that are happening. This is a relatively minor inconvenience, the Moomba Parade, and a more major inconvenience. If this keeps happening, it's going to be sort of awkward for our transmission lines. But the most important thing is to remember, when people say, oh, it could get bad sort of later on, it's very bad already in a lot of Africa, in Bangladesh, some years ago, the third underwater. Imagine if Australia was a third underwater, all at the same time. We worry about emergency services if there's like a flood in Lismore. This is a third of the country underwater. Anyway, so I won't dwell. It's just a snapshot. Because the really scary thing is the acceleration in the warming. And anyone, how you talk about it, we have reached 1.5 for a 1 year average. Now, the people who don't want to alarm the public like to say, oh, but the IPCC, they're talking about a 10-year average or a 20-year average. We won't know for sure we're past 1.5, for years and years and years. Well, what Hansen says, and I do accept James Hansen on most things, is that for all practical purposes, we've passed 1.5. He's expecting 1.6 to 1.7 this year. Hang on.
Who's James Hansen?
James Hansen is an extremely eminent climate scientist, former head of the climate department at NASA. But he is the first one that sort of sounded the alarm way back when in front of Congress and said that we have detected a warming signal in amongst all the, the changes year to year. Anyway, he could not be more eminent, but he has been trying to sound the alarm since, way back about 2007. He wrote a book called Storms of My Grandchildren, back about 2010, just talking about how incredibly bad out of control warming could be in very concrete terms, to the point of storms that can shift whole great big boulders. Anyway, last year, you can see the year 2023, like so far above any other year. 2024, even further. And so what Hansen says is that warming is accelerating, And it's not just El Nino. Obviously El Nino's feeding in, but even after El Nino, he does not expect it to go back below 1.5. And that's because the heating's accelerating. Look at that nasty little peak up there. It doesn't look like much when you call it 1.8, but that's equivalent to 5 nuclear bombs per second that we're putting into the ocean, mainly. So this is what I've said again on GAW and a lot in the media this week. The scientists are absolutely freaking out. There's people who are very conservative IPCC scientists who have always gone, oh, we mustn't scare the public and it's probably not that bad and, we've got ways we could fix this. They're using phrases like gobsmackingly bananas. They're just all over Twitter, which is now X, saying this kind of stuff. Saying that they're panicking, that it's really, really bad, that they can't explain why it's accelerating. And of course, the big worry we've got is that beyond 1.5, we're in the danger zone for runaway warming. It doesn't mean it's guaranteed to happen, but it's in the danger zone. And we know that from a paper, a very famous paper, the Hothouse Earth paper. It's its nickname, but if you Google it, comes up. And that was with Will Steffen and various other famous scientists, very, very eminent scientists. And what they say is not that it's guaranteed to get run away between 1.5 and 2, but they can't rule it out. We're in the danger zone. Now, if we were in the danger zone for the collapse of a bridge, would we just go, oh, well, we're not really sure, so let's just keep going? No, we're in the danger zone for everything falling apart. So maybe we should keep going. Because we don't quite know where the point of no return is. There's a whole lot of things tipping. There's a whole lot of things that seem to have some momentum in the system now. What we're afraid of is a cascade of tipping points that feed into each other and get so fast and so strong that there's nothing we can do. Like the way that a ball starts to roll down the hill, and there's a point where it's got its own momentum that you can still run after it and catch it, and there's a bit where it's just going so fast you can't catch it anymore. So somewhere past 2, we're definitely in the so fast we can't catch it category, and hey, we're at 1.5. One of the things that's very scary is the risk of a blue ocean event in the Arctic, and it doesn't sound like much, and people talk a lot about the albedo, the lack of reflectivity as being a big problem, but there's another problem as well. It's to do with energy in the system, and if you put a saucepan of ice blocks on the stove, you put the stove, turn on the heat, melt the ice blocks. Right before the last ice block melts, you can put your finger in the water. It's barely warm because all the energy is going into melting those ice blocks. As soon as the last one's gone, then the water heats up. Within a very short period, it's boiling. That's what we're risking in the Arctic. It's not just the loss of the ice, it's the energy that will go into heating the sea. And of course, another really scary one. Look, I said I wasn't going to do too much, but here's a couple more. Is the slowing of the currents. Have you heard about the slowing of the AMOC, the Atlantic Meridional Overturning Current? It's because up there in Greenland, there's so much melting ice going into the sea, so much fresh water, it's interfering with where that current is meant to sort of overturn and go back the other way. It's slowed 15%, but latest research shows it could stop. It could stop. I'm sorry, I've got some pent-up anger from doing these things on the media. Did this get in the media? Look, it probably got in the Guardian somewhere, right? How serious is this? They're saying this is like the day after tomorrow, except not quite. The day after tomorrow is the film where suddenly New York freezes. Now, it wouldn't happen overnight, but they're talking over a period of decades that whole segments of the north of the world could be so cold you can't grow food, and whole segments of the tropics could be so hot you can't even live there if these currents stop. Same thing, like, are we willing to take that risk? And why is no one talking about it, including our politicians? So this was Will Steffen. He used to go to court for Extinction Rebellion. He was a real treasure. The tragically died. He gave us this. He gave it to Violet Coco, actually, and then confirmed it. Literally his dying days while she was in jail for the Sydney Harbour Bridge. On our present trajectory, we risk heading into a collapse of our globalised civilisation, a precipitous drop in the human population, put simply hell on earth. he wanted to be clear that this was something we could tell people. And look, he's not alone. There's lots of scientists. They don't think we're going to stay at 2. They think we're heading for 3. And 82% in this survey thought that they would see catastrophic impacts in their lifetime. And they're not all spring chickens. Anyway, this is one we're giving to politicians to try and sort of concretise this. This is at 2.7 degrees of warming. And what you're seeing there in the shaded area of Australia is the parts of Australia that by 2060, 2070 maybe, are uninhabitable. But not just that, like look at all the bits of Africa and Southeast Asia that have also got that shading. Can I take the questions at the end?
I'm just wondering what colour you're talking about.
I'm talking about this colour.
Right.
See that bit? And all those bits in there. And look at India. Look at the Middle East. These are possibly so hot that you can't live there. So, we are on a pathway, obviously, to complete disaster. We have to get to zero emissions, obviously, as fast as we can. That is not easy. Like, we're up against the incredible force of the fossil fuel industry. And by George, they're harder to defeat than I ever thought they were going to be. Even if we completely defeat them and bring them to their knees, that only gives you the orange line. It means that the concentrations of atmospheric CO2 and the temperature, it stops increasing, but it goes down incredibly slowly over centuries. So when you're calling for zero emissions or you're talking about emissions reductions alone as though that's going to save us, it is just not true. You have to do drawdown. So that's the blue line. If we can do massive drawdown, like massive, we can bend it like that blue line. We have to, but the problem is we don't know. That's the dotted orange line. That's the point of no return. We don't know exactly where that is. We could be past it already, hopefully not. What we need, if we want to stay safe, is active cooling. So we actually have to look at some protective measures while we do the incredible emissions reductions and the drawdown. That is the fact of what scientists are saying. And it's no use just pretending that a few more solar panels are going to fix this. It's possible to fix it, but we've got to get cracking. And Elly is going to tell you how we can repair the land and what a difference that'll make. Afterwards, I'll talk about the sea and some other measures, including the climate repair.
Thank you, Jane. Honestly, it's really an honour every time I get to present with Jane because she's just honestly such a legend and a powerhouse, and she does all of the things that the rest of us are too scared to do. So thanks, Jane, for all your work in this and inviting me to come and speak to you today. So yes, my name is Elly Hanrahan. I have a degree and I also work for, maybe controversially, the state government in the Environment Department, but as part of that role I do get to respond to emergencies as a forest firefighter. And after I did my first season as a forest firefighter, I ended up co-founding AusRegen, which doesn't exist anymore, but it's the reason that I met Jane, and through Jane, or through my crazy mentor who's called David Marr, I learned about these methodologies and I've become incredibly passionate, and I wrote a policy paper on it, and like Elizabeth said, I presented it at the UNFCCC's climate COP in Egypt. So I was born in 1995, and that makes me pretty much an adult now. I'm almost 30, but I've actually never lived in a year of below average temperatures. I'm gonna walk around. So I was born here, and I've never lived in an above average temperature year. I have, however, got to experience quite a few, record highs, and that becomes pretty serious when you're actually the person to fight fires because of those incredible high temperatures. So I was shipped off my first year to fight East Gippsland fires, and one of the things that I had the horrific pleasure of experiencing was watching pristine temperate rainforest burn to the ground, which was pretty devastating to me because I had just paid a lot of money for a very expensive science degree, and they had told me that the key characteristic of a rainforest was that they don't burn. Full stop. That's in all the textbooks. So something had to be really wrong, and I realized that, you know, even though I'd spent my whole life advocating for renewable energies, solar technology, that was not going to be enough. There was something so broken on the ground here that even if we magically stopped emissions tomorrow, it wasn't going to make a difference to these fires that we were trying and failing to fight. It's obviously not just fires though. Maybe I won't do this anymore. It's not just fires. We know that climate change isn't just about fires and drought. It's also flooding. It's climate extremes. And we seem to be just getting hit with these wave after wave after wave. We've got the Lismore flooding, the Perth flooding. I think this one where, you know, in Perth, 20 years of Perth's water use flowed down the Fitzroy River in a day. A little bit further out, we've got, you know, landslides, and you know, I know that Jamie, you did a lot of this, so I'm just gonna flood through, but you know, rain isn't really supposed to fall in the Arctic. It's one of the driest areas on our planet, those Arctic spaces. So what the heck is going on? Yes, the Earth is getting hotter, but it's not just about greenhouse gas emissions, and that's kind of what we're going to walk through today. There are other processes that are happening that are on the ground, and actually this is a hopeful presentation. I know it started off a bit sad, but it's a hopeful presentation because there are things we can do. It's, you know, it's not just fighting like the big oil companies. There are things we can do practically on the ground today to try and alleviate some of this problem. And the IPCC has actually acknowledged this. This quote says, "The role of landscape processes within the climate assessments has been mostly ignored, except in terms of how carbon assimilation is affected." Now, the key term in this is landscape processes. Landscape processes. How is everything happening on this complex planet? How is it all working together, and how have we broken that? So that's what we're going to try and go through today as quickly as I can. And unfortunately, we have to start off with physics. And don't shut down or go to sleep or anything. We're going to make this really easy. I'm going to try and break it down as simple as I can because, you know, I did study a bit of chemistry and physics at university, but I wouldn't really call myself a physicist. So the first law that we're going to look at is the law of thermodynamics, is the second law of thermodynamics, the law of entropy. Now, when we think about entropy, it's the law of disorder, right? Naturally, in a physical environment, everything naturally wants to descend into disorder. And when I say everything, I mean energy. And when I say energy throughout this presentation, the best way that we feel energy is via heat. Heat is energy, energy is heat. And something that made me really understand this was when someone said there's no such thing as cold. There's no such thing as cold. You either have energy or heat, or you have the absence of energy or heat. So when you think about that, and you think about energy, all it wants to do is just spread out. It doesn't want to touch other energy. It wants to spread itself out as far away from everything else as it possibly can, just naturally. So when you think about that in real terms on Earth, what that means is hot air will move to cool air. We've got a lot of energy over here, it's very, very hot. There's not so much energy over here, that energy will move over towards cold air. So hot air will always move towards cold air. The second law of energy that we're going to talk about is the law of conservation of energy. This one you've probably heard about. Energy can neither be created or destroyed, only transformed. And we're getting energy from the sun all the time, every day. 24 hours of the time, the sun is injecting a lot of energy into our biosphere. And that energy cannot be destroyed, we have to deal with it. Something has to happen with that energy. And if we don't do something with the energy, we've got all of this heat, and this creates sort of a bubble. So we've got hot air coming, energy coming in from the sun. As it sort of, you know, reflects off a dry, barren desert, we've got energy going straight back up, and we're pushing out. And so as you can see here, it creates a dome that won't allow cloud cover to pass over where that energy is expanding out. It wants to go to where energy isn't, and cloud mass is a cooler phenomenon in our atmosphere. So this is a great example of how, if we're baking something, if something's getting so hot, that force of energy is going to be enough to overcome any other natural forces that are happening in the atmosphere, including creating this fun little square over the road. Zooming out, this happens on a much bigger scale. We've cleared that southwestern part of Australia. That's all very dry, wheat belt sort of area down in southwestern Australia. So we see this a lot where we have our predominant wind coming in from the west. That's coming in with cloud cover, but it's skipping that area. So that rainfall can't occur there because it's just getting baked by the sun energy that's coming, and that sun energy doesn't have a job to do. And energy is actually really helpful. It's the reason that we're all here and alive. It's the reason that we have plants and, matter. And it wants a job to do. It really, really does. It wants something productive to do. But like humans, if we don't give it a job, it gets kind of bored and it starts to be destructive. So when we have energy coming in, whatever I was going to say there. So we don't have, when capacity to input solar energy into the landscape is lost, that equivalent energy is exported elsewhere. So this is a great example of a lot of energy coming into a system all at once and sort of causing chaos. When we scale up, we can see those phenomenon in dust storms, blowing our precious topsoil off into the oceans. And really, when you look at these two phenomena, the dust storm and a rain bomb doesn't really look that different. It's just made up of different stuff. And that's because essentially it's caused by the same energetic reaction in our atmosphere. And we get things that we're all familiar with. So the rain bomb is kind of something new that's in the media. Essentially, what happens is we have an atmospheric river in skies above the lower atmosphere. So in the upper atmosphere, that is where we can have these atmospheric rivers happen. If that upper atmosphere warms up, there's so much energy in there that it actually has the capacity to hold a lot more water up in that upper atmosphere and move it across landscapes and then just dump it. So as our climate is getting warmer, that does mean that we can hold more water in the upper atmosphere. And things like this happen. So, what is the enemy of entropy? It's plants, actually. Plants are pretty much the only biophysical method that we have that can reduce entropy, and that means bringing energy in the form of sunlight or heat and putting it to good use through the plant process of photosynthesis. So we'd all be pretty familiar with photosynthesis. The sun energy comes in, the plants take that up, they convert it to leaf matter and also oxygen, that's how we can breathe. But it's also releasing water vapor into the atmosphere. Plants breathe water vapor out in the form of H2O. So if we consider these two sides, we'll start on the right. There's a lot of sun energy coming out. I'm just going to go away from the mic. So there's sun energy coming in here. We're not getting a lot of reflection from the clouds because there is none. It's coming straight down, hitting this really dried out landscape and bouncing straight back out into the atmosphere in the form of sensible heat, which is a misnomer because sensible heat is, like what I said before, destructive heat. There's not a lot of cloud cover in here, so there is some sort of evapotranspiration happening. That's the blue. So that's energy that's being converted into water vapor via plant matter. And once that hits that upper atmosphere, it will condense because it's getting cooler. And so the water is condensing into clouds, and because we've got, lots of, a smaller, what was I saying? Because we have a area of water vapor, we do lose a little bit of energy back out into the atmosphere. So that's that red one on the right. When we have plants, it's putting that energy to use. And most of the energy that gets expelled is via evapotranspiration, which will create cloud cover. This is pretty much another version of the same thing. But the energy is always coming in and out of the system. There's nothing we can do about that. But what we can do is figure out what job we give that energy when it gets to our Earth's surface. And so if we have a lot of sensible heat or that destructive energy in our environment, that will cause steep pressure gradients and extreme weather. Latent heat, which is the heat or the energy that is stored in water vapor, can actually smooth those pressure gradients and calm weather. And that's because it's still energy in the system, right? It's still water vapor hanging in our atmosphere, but it is energy that's keeping it there. So you don't have this void of air that's like void of energy. And so when you have these like big pressure gradients coming in, hot air rising, it can't just rip through and create these big currents. You've got this energy here that's smoothing that out. Remember, energy wants to space itself out. There's already energy in that system just hanging out as water vapor. So it can't come through and create those destructive forces. So we know vegetation, I'm just gonna keep going. So a great example of how vegetation can cool. A great way to prove that vegetation can cool, at least sometimes we think, oh, it's shade. Shade is cool, yes. But also, there's not a lot of shade happening in that middle strip there to cool that air around it. So why then can it be 20 degrees cooler if it's not just because of shade? It's because of that water vapor that those bits of grass that are still left is giving off. And then you take a step to the left even further and you drop down another 5 degrees because you have, a more intact sort of part of vegetation that's giving off evapotranspiration. Okay, this is a good one. Okay, I've actually sped this up to 1.25. So hopefully.
All around the world, traditional wisdom has it that forests bring the rain. Scientists have scoffed at this notion for a while. The forests grow where there's ample precipitation, but they do not cause that precipitation. It comes because of winds that are governed by geomechanical processes which have nothing to do with where the forests are in art. Water does not tend to stay in one spot for very long. Most of it ends up running off into the ocean via rivers. Unless there's some way for the moisture from the ocean to come back inland, all of the land's water would be gone very quickly, as with the forest. According to the geomechanical view, moisture gets transferred inland when water vapor is carried from the ocean by winds. Because some of this water gets lost to precipitation, the deeper inland this air gets, the less moist it becomes. Therefore, deeper inland means less rainfall. If this view is true, we should expect to only see forests near the coasts, and drier, more arid areas the farther inland we go. But this is not what we find. Where there are still natural forests, precipitation does not decrease with distance from the ocean. In fact, it often increases, the greatest amount of rainfall being in the deepest parts of the forest, sometimes thousands of miles from the coast. This is unexpected and difficult to explain with the geomechanical view. What on earth could be attracting so much water to a spot so far from the ocean, and why? While there is more water in the ocean than in forests, forested areas have more water vapor in the air. This is because forests, especially healthy ones, have a lot more surface area for water to evaporate off of. Multiple canopy layers, shrubs, moisture-laden ground are all full of water, which transpires or evaporates, entering the air. As a result, we find much more water vapor in the forest, even when there's less total water. The ample amount of water vapor in the forest rises and condenses into clouds, changing from gas to liquid. This creates a drop in air pressure, which allows even more vapor-filled air to rise. This creates an upward air current, which in turn creates a horizontal current closer to the ground. This sucks in air from higher pressure areas, like the air from over the ocean. This air contains some water vapor, which increases the total amount of water in the forest, leading to more frequent rainfall. Essentially, forests create a giant constant air current that attracts moisture from hundreds of miles away. This is how we find so much water so far from the ocean. The forests bring it in. This process is known as the biotic pump, and it shows how traditional wisdom was right all along. Forests really do bring the rain. So as more forests are clear-cut, the more extreme become the droughts, and the more expansive become the deserts. If we want to thrive on this planet, we need to preserve and regenerate the forests.
in another video I present to you, which is actually Jane and David speaking.
2005.
Let's have a look
So
at
we're
that
looking at how
happening
the
in real
forest
time.
systems are actually pumping water from one forest to another. We're also looking at this little piece of Africa up here, the desertified area, and how we don't, on occasion there's precipitation events going through there, but mostly speaking, that land surface heating will direct the clouds around it. We can clearly see that vegetation is responsible for managing the hydrological cycle. Yeah. Thanks for that, Jane.
Thanks, Jane.
Thanks, Dave. It's like
There
magic.
you are. Thanks, Jane, for letting me steal that one. Okay, so now that we know those things, we know that rain falls where vegetation grows, and we know that rain is very important because of all of the things that I mentioned before about heat, currents, and I'm just going to skip over that, Jane. I know it's important. And something else about ensuring we have a lot of vegetation on the land is runoff, which we know because as we're clearing land, we're actually reducing the ability for a landscape to hold water. So even when rain does fall in land, it's pretty much just sheeting right off the top, taking our topsoil with it and polluting our marine environments. Now, as I mentioned before, we have a predominantly western climate, and that's because as the sun moves around the earth, heating it up, hot air moves to cool air, and that air will come in as the sun moves away from us. It will come in to where it's just been nighttime, and it will bring whatever has come with it. So we've always got a westerly weather system, and when there's a heat wave, that will spread out. Even if it starts in a relatively small area, that will spread out via our predominant westerly currents and spread across Australia and enlarge in size. And there's not much that will overcome this. But there used to be. So there used to be a phenomenon called the Tanami winds in Australia. And that was where large amounts of water vapour would actually come in off the eastern coast of Australia, overcome that westerly predominant wind direction, and drop a heap of water in central Australia, which doesn't make sense because we know that's very dry, that's very, it's very hot. We've got a lot of hot air moving and pushing that cloud cover away. So it doesn't make sense that we would have these frequent winds that would overcome that wind current and go into central Australia from the east. But it used to happen because the eastern coast used to be beautifully vegetated. It was phenomenal. We had, I've messed up my slides here. I'll leave it on that later. So what am I saying here? Oh yeah, of course. Once we hit Australia, the land mass, because it's being dried out and devegetated by colonizers essentially, that will move on to our marine environments and cause marine heat waves, which destroys our reefs. Now, I know this is from the Sydney Morning Herald, but they did get something right. So in January 2019, this is the Black Summer, what happened was very surprising to a lot of climate scientists, because usually a warm air mass from the Australian outback would be cooled significantly by contact with the Tasman Sea. But because Australia had been so hot for so long, it had actually warmed that eastern side of Australia and warmed up the ocean between New Zealand and Australia. And this allowed this giant mass of hot air to actually travel across the Tasman towards New Zealand. And what has happened there is we've kind of overcome a normal cycle of heating and cooling. When New Zealand got this massive push of hot air from our... So in this verse, this is like a normal sort of thing you would expect to see within this area of the world. We have beautiful forested areas up there. We've got the Daintree that's cooling a lot of Eastern Australia, and it's actually pulling in water vapor and currents from the seas. What happens when this gets really hot is that starts to reverse and create kind of this swirl pattern where these two currents match up and merge. And you can kind of guess what that creates. So that created Cyclone Penny, which was devastating for the Pacific Islands and also Northern Australia. And this is going to happen a lot more often because, you know, what we do here, sure, we're degrading our own soils and we're devegetating our own land masses, but it's actually, you know, a global phenomenon. What we do here really matters in our neighbouring countries and indeed, you know, all across the world. So obviously, let's just plant a lot of plants, that's easy. We'll just get out and we'll plant forests and we'll do it, but that's not as easy as it sounds. Oh, sorry, Jane. That's not as easy as it sounds because the water cycle is broken. Let's go back a little bit and talk about what Australia used to look like. So we have a really ancient, dry continent. It's very flat. We don't have recent volcanic activity. We don't have lots of nutrients flowing down from a giant mountainscape every time that the snow melts. So Australia has had to sort of evolve to figure out its own nutrient cycling and how it was going to manage water. And Australia did this traditionally with these chains of ponds. And these are depicted very commonly in traditional artwork and knowledge. And essentially what they are is individual pools of water that are connected underground, but they also join up in the wet times to create a larger system. And so, you know, in Australia, we used to have very soggy, boggy, like spongy soils where water would fall inland and it would very slowly kind of meander its way out to sea. And that's what we see here. Once settlers came and they were like, great, these soils are perfect for grain and sheep, what happened was pretty much we just drained all the wetlands and we got rid of the root structure that was holding all of the water laterally as well, because wetlands actually act as a bit of a plug in the environment. So even though you can't see it, there's water, you know, spread out laterally underground in aquifers, and it's held up even higher than the wetlands themselves because there's all of this positive pressure coming from the root systems. Once we got rid of that, the root systems gave way to erosion, and this kind of channeled out all of the water in that area. So it all flowed through from the top of the hill down to the bottom of the hill. It was very hard for plants and vegetation at the top of the hill to kind of get their root systems down low enough to get that water. And so you've kicked off a positive feedback cycle where, you know, we don't have a lot of evapotranspiration anymore because we don't have the vegetation. And then because we don't have the vegetation, we can't hold the water in the landscape. And so it's sort of, you know, eventually what you'll find is these big eroded gullies everywhere. And you guys live in, So it looks like, what they think is that 96% of the wetlands have been removed from Australia since colonisation. 750,000 wetlands just in the Murray-Darling Basin alone. And Indigenous knowledge, a really important part of Indigenous knowledge is water management, and that's something that we don't hear much about, but fish traps are one example of how water used to be managed in these areas. You know, lots of rocks very carefully placed in the waterway would slow down the water as it moved through the system, trap sediment above, and sort of create this fertile bed for wetland plants to grow and flourish, and separate out the channels into those leaky weirs or those chains of ponds. Of course, when settlers came, they were like, oh, all of these rocks just very conveniently placed in the waterway. I might grab them and we can build other stuff with those. So pretty much all of those were very quickly removed. And actually, this wording says that, I think it was 13 years the paddocks just like completely eroded and dried out. And that was all it took, just taking, Jane, what were we saying in this slide?
Just as soon as you don't have the chain of ponds, like it only takes 13 years to go from a fertile landscape to that.
Yeah. And we're in Nillumbik here, so I thought I'd show you some photos of your own backyard. So this is Watson's Creek, which is actually co-managed by traditional owners here, but you can see that, you know, that's my Toyota RAV4 up the top. If you were to put my RAV4 down in the bottom of that gully, it's like 2 to 3 times the height of the RAV4, and that is not what Australia's landscapes are supposed to look like. We're supposed to have very shallow waterways, very high beds, lots of water spreading out laterally, but what's happened is water has come rushing through here. And I think because it's a gold mining area as well, it's kind of particularly relevant because a lot of channeling happened here. And Elizabeth did mention my research, so we worked to, this is my research team, and we worked to rehydrate these gullies as well, and we found that the chains of ponds worked almost instantly. You could actually go there right now and you would see a completely different environment, and I really should get some pictures of those. So all of this is to say that if we act now, it's not that hard to reverse those landscape processes that reverse entropy and the cycles that are being kicked off in that system. And Jane is about to speak about some other things that we can do. It's not that hard to draw down carbon. We have to work with Mother Nature. We can't keep working against her. You know, she's putting things in places because that's where they grow best. And we have to start to understand that, you know, we can work with her. So that's what the methodology that Peter Andrews works with does. Natural sequence farming, otherwise known as the landscape rehydration methodology. Reducing erosion by allowing those pioneer plants or weeds to grow and re-fertilize the soil. Putting those fish traps back into an environment so that it has the chance to kind of kick off, slow that water down, take out the erosive energy, and start to rebuild those chains of ponds. And when we do that, the aquifers and floodplains are recharged with slow release during dry periods, because Australia is prone to very long dry periods, but we need to be holding that water in the landscape to account for that. And so shortly you would see the beginnings of the short water cycle, which I didn't really go into, so we'll skip that. And of course you're holding a lot of carbon as well if you're doing these methodologies, because you're growing a lot more plants, because there's a lot more water that can grow the plants. If we rehydrate and restore upper areas of the catchment, that means that we're going to have less flooding in our built-up areas, which we very conveniently built on the floodplains. And so what's happened is 2 things. We've built on the floodplains, but also we've allowed the water to move a lot faster through the system. So once water goes through, it doesn't have anything to slow it down. It's just going to come straight down into the floodplains. So if we can put that meandering back into the system, the landscape will be able to process that water before it gets to our built-up areas. So it's a win-win-win, and I'll hand back over to Jane.
Thank you. And look, yeah, Elly did mention Dave Marr. Like, we both have learned a lot from Dave Marr on this, and I did credit him at the start, but forgot to say. And also some of those slides of mine with the white backgrounds were David Spratt, who of course is an incredible person who just has dedicated his life in recent 10, 15 years to simplifying and explaining the emergency science in ways that ordinary people, even politicians, maybe if they looked, could understand. So these are just some examples. Like, we already know this stuff can work. This is the Los Valley in China, which was incredibly fertile and farmed for 3,000 years before it was turned into a desert earlier this century, last century. But in 12 years, oops, I lost a slide, oh dear. Anyway, I have to say, in 12 years, they managed to restore that. And within a very short time, then, I did have a quote just saying that I was startled by how quickly things just grew back, even after hundreds of years of the the natural environment being displaced. It's another example, a marsh project in San Francisco. And a very exciting one is the Gascoyne River in Western Australia. The former agriculture minister went and had a look at Yanjit, which is a Peter Andrews property in Western Australia, was blown away by that phenomenon that you just saw, like where it's green on one side of the fence and red-brown on the other side. And she actually dragged the Premier up for a look. And now they're actually in the process of restoring the whole of this large river in Western Australia using that Peter Andrews method. So working with the landowners right up the catchment to slow the water down, basically. It's so obvious, isn't it? Once you think about it, like it's so obvious that if you slow the water down, there'll be more water in the landscape and you can grow more stuff. And yet you have just people just trying to do this, plant more stuff without the more water. It's crazy. So yeah, it's based on Yanjit, which is an amazing property. They tried very hard, they put a very detailed proposal for the Fitzroy River, which is that one that took out the Fitzroy River Bridge with some percentage, some massive amount of water. That was opposed by some of the landowners who refer to have dams to their cotton farms, including Gina, dear Gina. I don't know whether that changed their mind now. They took out that Fitzroy River crossing because there was months and months and months that all the transport that was going from the centre of Australia up to Broome had to go 3,000 kilometres or something to go around this broken bridge. And I just did have good wishes from Dave, who sends his apologies for not being here. He's on a boat coming, on a yacht coming down from north, and he did give me an update on this project. Somebody who's very much linked in with Ausdridge and with Yanjit and with the Peter Andrews thing, someone who used to work for the agriculture department in Western Australia, is literally in Indonesia as we speak, working on massive rehydration and revegetation projects, like just huge. Like, I don't think this one's, there's some in Indonesia just literally about to get off the ground. They're looking at things like revegetating the whole of East Timor. This is not just someone's back garden. So these are incredible, and the good thing about tropical rainforest is if you give it half a chance, it will, it's just busting to regrow. But I'm talking about the sea, so I will get onto the sea, and I'm sorry, I'm going to eat a little way into question time, but it's good stuff. So like I said, you've got to do the reduce emissions, but you've got to do the drawdown. And a very inspiring book which you can download from the internet is Peter Fikowski. So he's I think a businessman with a science background. He's looking at these 4 methods that he thinks are the most promising. So it's synthetic limestone manufacture, seaweed permaculture, and ocean iron fertilisation. Otherwise, which doesn't sound very exciting, but otherwise known as mimicking, processes mimicking whale poo. I'll explain. He's also got an interest in trying to do something with methane release protection. Like one of the really bad things that can happen in the Arctic, if the ice is gone, is methane that's stored in the permafrost and under the sea can be released. And of course, that's a horrifically powerful gas. So, talk about optimists. Like I'm not guaranteeing this, but he thinks he can make a business case and a science case that for 2 billion a year, we could get back to 300 parts per million from over 400. For a cost of 2 billion a year. It's really chicken feed, isn't it? And I like that quote from him. He says, "Why am I so confident?" He's looking at processes that are the same processes that the Earth naturally uses as the Earth is heading into an ice age. And he's only looking at methods that are permanent, scalable, and financeable, being a businessman. So if any of these work, and there's a real chance that possibly that all of them will, it will be incredible because it's quite large scale. One of them is synthetic limestone, so it actually is using air capture of CO2, which is easier obviously from fossil fuel burning infrastructure, but you can do it from the air. It costs more, of course, but that has already come down in cost massively from $600 a tonne to $100 a tonne. So hopefully it's on that exponential curve. And this is a replacement for concrete. How much concrete do we use? So that could all, in theory, be replaced by this limestone made out of CO2. Seaweed permaculture is something that a lot of people are keen on. And again, like, this is amazing, it doesn't get talked about as much, but yeah, kelp can grow 2 to 3 feet per day, and kelp forests draw down more CO2 than the Amazon, acre for acre. Shouldn't we be putting a bit of effort into keeping our kelp forests, planting more, finding, heat-resistant kelp varieties? There are people working on it, but imagine if it was treated as an emergency. Imagine if we threw everything at this problem. How much faster we could go. But yes, kelp, fantastic. It needs nutrients that can be brought up from deep in the ocean using solar energy pumps. And it's great not only because of the drawdown that you get from the kelp, but because you actually can regenerate whole ocean ecosystems. Because as the kelp grows, the fish come. This is a pest seaweed that's growing too prolifically at the moment, but it's Sargasso. I guess it's seaweed in the Sargasso Sea. It's washing up on resort beaches and causing a terrible smell, but you can actually make fuel out of it. And my favourite is iron ocean fertilisation, mimicking whale poo. So we've got a biotic pump on land. In the sea, we used to have a whale pump till we killed 99% of them. So now we have a very weak whale pump. How the whale pump works is that whale swims down to the bottom of the ocean. There's more food down there, and also the pressure is so enormous that it actually can't poo even if it wants to. So it eats all that stuff, comes up to the surface, does a giant poo, which spreads out over the top of the ocean and is the main food for the phytoplankton. So it's only 1% of what it used to be. The incredible thing that we can do though, is fertilising just ocean eddies. So they're a bit like a paddock in the sea. It's like where the water's going around in a circle. You don't want to just throw iron, everywhere. You can't do it over vast areas. But you can fertilise an eddy. Most of the areas only need the iron, but some of them need some other stuff as well. It's readily available either as desert sand or as volcanic ash. You fertilise it, the plankton blooms, and the interesting thing is that in the ocean at any time there's trillions and trillions and trillions of fish eggs just floating around, right? Because fish have so many eggs, right? What's happening at the moment is the little fish eggs hatch and then they immediately starve. There's nothing for them to eat. So again, with just the application of iron and the other minerals if needed, you can get an immediate increase in the fish. And that's at the bottom, working all the way up. The people who are working on it think that if we did this for 30 or 40 years, again, it is not expensive. We could actually regenerate the whale population, and in 30 or 40 years, they'd be doing the pooing. We wouldn't have to do it anymore. I think this is just an incredible story. And the sad thing about it is that it's already been shown to work. There was an experiment near Canada, initiated by the local people who had to pay an entrepreneur to get it to happen, because governments and, unfortunately, greenies have been opposed to this unnatural process. They showed that it massively regenerated the salmon in their area. They had fishing 4 times the amount of salmon, but it was shut down by the environmentalists who didn't want the moral hazard of showing that you could do drawdown in case it stopped us winning against the fossil fuel industry. I don't think it was a great decision, Like, we do need to fight the fossil fuel industry. It's turned out to be a bit harder than we think. But why not regenerate the oceans at the same time? I don't think it's either or. The methane release protection is it's an acceleration of natural methane oxidization. Again, a very simple process. That this is just to do with minerals that could be distributed by ships that are sailing the ocean. And they would oxidize the methane, thus stopping it getting into the air and heating us up. We just need the will to research these things. It's not expensive. And we are in such danger from methane release. We want to be sure this works. We want to get it so it definitely is scalable. And last but not least, Sir David King was advisor to the UK government. He's now working with his own separate institute. And he, when he was visiting Melbourne a few years back, he said, look, we've only got 3 or 4 years left to cool the Arctic and Antarctica and the Himalayas, which, you know, he sometimes says 3 to 4 years, sometimes he says 10 years. Anyway, we haven't got a lot of time. It's that same thing. We've got to stop that ice melting. But the good thing is that, again, he is working on techniques that could work, and that is marine cloud brightening. So this is just whitening the clouds where they need it. So over the bits near the Arctic where the warm water is, we could cool the water that's melting the Arctic. And interestingly, one of the projects that we sneered about under Morrison, do you remember the idea that we could cool the Great Barrier Reef? Oh, yeah. And we went, oh, you know, what greenwash? And it was, you know, because it was an attempt just to, you know, treat the symptom and not the cause. But they're actually making progress. And there's a lovely video which it's too hard for me to show you, but it shows the scientists on this ship and saying that from just a thimbleful of water, they can get billions of droplets. And the best thing is that they're finding that they actually take themselves up into the clouds and whiten the clouds. So there's a very real chance this could work. Again, we've got a little bit of research going on. Imagine if this was treated like an emergency and they really got cracking on this. We've got Sir David King sort of waiting for the results of the Great Barrier Reef crew to see whether they can go ahead in the Arctic while he is passing. Yeah, so that's the thing. That's the thing. They're trying over the Great Barrier Reef. And it's good to find some good news. That they're very excited about the fact that it seemed to be easier than they thought, rather than, I would have thought maybe impossible. But that's them making the water vapour. Has anyone read Ministry for the Future? It's a sort of interesting, depressing, inspiring, incredibly detailed novel about the future, and it's a good guide. It's quite optimistic after a really pessimistic start. One of the interesting things in it is that they've got they actually try things to slow the glaciers down, to plug up the glaciers in Antarctica. Because the problem we've got with Antarctica is the warm water's getting underneath, it's melting them from underneath. But there are literally people working on this right now, to walls and dams. If you can stop that warm water getting under, you can slow the melting. You can't completely stop it. It's not impossible. It's not impossible. It's in Ministry for the Future, and it's because the guy who wrote it actually does talk to Sir David King, and Sir David King is also working on this. So these are amazing things which the governments need to talk about, activists need to talk about. We've got to stop opposing them because they're unnatural. We've got to get cracking. Just a little bit, we've got to get cracking. We've got to push for emergency action. This is just some of my favourite activist quotes. This is from Christiana Figueres, who's one of the negotiators in the Paris talks. And she basically is calling for civil disobedience. That's her opinion of how the political process is going. And so does Guterres. He says we need disruption to end the destruction. So that's why we're where we are, disrupting the city right now. And Kevin Anderson, scientist, he says the same thing. He says we've got only a 5% chance of staying under 3 to 4 degrees of warming, and that chance comes from Extinction Rebellion and school strike. So you don't all have to come and join us on the streets, but we would love your support, or for you just to work in any other way to push for politicians talking about this to the public, educating the public. And we've got to just find a really relatively small amount of money and the emergency mentality. to get this stuff happening. So, whatever you can. There is another branch of Extinction Rebellion apart from the one on the streets, which is the Tell the Truth crew, and we literally are just going to politicians, telling them this stuff. We've got a thing from David Spratt on the 3 R's. Reduce emissions, redraw emissions, repair. 3 R's. And we're taking it to politicians. They don't know. They don't know. The Morrison government destroyed their sources of information, like the CSIRO and the Bureau of Meteorology. They just don't know. So there's a very real role in just going and telling them that it really is that serious. So that's it. Sorry about the question time.
Thank you, both Jane and Elly.
Yeah, thank you.
There was lots of depressing stuff there, but there was lots of inspiring stuff as well. And it's fantastic to hear about some of these solutions. They're not often talked about, and they need to be. We're in a situation where we need to put everything on the table, and we need to be talking. And I'm really grateful to you for coming to share all of this with us, because I think it's probably not talked about enough. Just before we break firstly, I want to give people an opportunity to ask questions. So I think we have a question up the back here.
Megan.
I'm really sorry for taking out your question.
I just wanted to know, from your experience, what would you advise Joe Blow average in terms of the most effective possible action you could take as an individual towards this end?
Join a group.
Join a group.
Yes, join Nillumbik, go and visit the politicians. When they knock back the duty of care bill, which they probably will, I would say go spray paint their window, but failing that, just write them an angry letter or something. Because they mustn't be allowed to get away. You've got to apply the pressure to the politicians, and you're better in a group. You can do it as an individual. Again, I would say probably that if you're doing it as an individual, the most powerful thing you can do is regularly ring your politician's office and just say, this is bullshit. What are you doing about this? Just send them stuff.
Okay. So you think you've found that you've got good results from that? Because I've written
totally.
letters and got form letters and
Yeah. No, they will give you form letters. It's better to ring.
Yeah.
Because then you're actually having that person-to-person emotional impact, at least on an advisor. You never get the politician, right? People are very influenced just by other people.
Yeah.
They want to please other people. So just an upset sort of phone call has an effect.